very much.
Bravo.
Yeah, we're in business. I'll go and turn the other mic.
Hello, everyone. We're going to give it about 2 minutes. So 2 more minutes. You're in Gaia. Really?
If I recognize her, I recognize her. While you're getting settled, we could really use a volunteer to take some notes. You don't have to capture every single word, but if you could capture the Q&A, that would be very helpful. Just raise your hand if you feel that's something you'd like to do.
Hello, everyone. Welcome to Gaia. We have an interesting experiment on today with most of our participants providing presentations remotely. So we're going to give it a go and see how it works. The agenda does have Lakshmi going first, but we don't see him yet in the room. So we're going to start with Adasorn in a sec. I've got to do a little housekeeping. So there are blue sheets circulating in the room. Please sign in. If anyone's willing to help us take notes, as Matt's just asked, did we have someone raise their hand to help us? Maybe. Adasorn will help. Thank you. Yeah, mostly the Q&A. We'll help you capture that. Thank you. Pardon? Yeah, there's a Jabber room open. And my name is Jane Coffin. I'm one of the co-chairs. My other co-chair is Leandro Navarro, and Leandro's in Spain right now. Matt Ford, who's sitting next to me from the Internet Society, used to also be a co-chair of Gaia, so Matt's giving me a hand today. So we're going to get started quickly with the just quick note oops. Most of you know the IETF IPR policy, but we just want to make sure you have the opportunity, sorry, this is a little bulky, the opportunity to see what that is. And it's online as well. So there it is. And here's our agenda and time plan. So given that we don't see Lakshmi, I just want to think we're going to ask you to go first. And do note that we are working on a mashup of a draft on different connectivity models, and we'll be talking to you about that toward the end of the session. So, Adasorn, one sec.
Okay, while we're waiting, so should we introduce myself? Good afternoon, everyone. My name is Adasorn Satthavi. So I'm a senior research associate at Interlab, Asian Institute of Technology. So today I will give you kind of the update of what we are doing here with the project called TACnet, which is the community network that try to provide the connectivity to the rural area of Thailand. And this is a list of my my co-authors that we're working together with Nisalat, Nantapat, and Bipun, our PhD student, Dr. Atapong is our faculty member from AIT, and Professor Kanchana Kanchana-Sud. Okay, all right. Actually, I might give you a brief introduction here because actually in the previous IETF, in IETF 102, I already present about the darknet already. Today, this is kind of the the slide is not quite fit with the screen, I think. Yeah. So this is what I'm talking about. So the darknet is the research project that tried to utilizing the wireless mesh network to provide internet connectivity in the northern part of Thailand called Mae district or in Ta province, which is a border between Thailand and Burma. We started this project since 2013. It's been about 6 years already, and we have already deployed about 17 remote villages already since then. And more than 200 routers that we have already deployed in those areas. And currently, more than 1,000 users using our network on a day-to-day basis. And this is some kind of the statistic that we have. So from 2013 to 2016, the darknet is run based on the volunteer. So we have the student and the volunteer from the local people helping us for the deployments and maintenance of the network. So we could not go so far. We can deploy almost about 1 village per year. So since recently in 2017, we changed the business model with the help from THNIC Foundation. And we call that the new business model called Darknet 2. So the details of the models I already mentioned, we already have documented and then going to be published in GIS Watch 2018. We're going to be released next week. So from then, we could be able to deploy the network. Like for example, from last year, we can deploy almost 6 villages 1 year, and this year we reached about 7 villages already. Okay, so in terms of technology, actually Darknet, is the extension of our old project called Dumbo, which is about to using the wireless mesh network to support the post-disaster scenario. So in Dumbo, we use the OSR routing protocol to create a wireless mesh, and that is the project that we have. And then we try to extend to use in the community network context. You can see that from the equipment that we use is most of them are from the off-the-shelf equipment like the TP-Links. I could mention that the small one that I'm showing on the right-hand side, on the light one, which is quite portable. So because the purpose of that, because we the villager can benefit from that, but when it's kind of disaster happening like a earthquake or flooding, the people the villager can take out the router and then they can create the wireless mesh immediately without any preparation or configuration, and that's the purpose of that. And we're also using another equipment as well to provide a better coverage area, like this one, the back one, and the white one, and so on. And of course, we use a Raspberry Pi to run our own local services inside the networks as well. Darknet is running so far for almost 6 years, but now since the network is scaling and we still have many issues, and one of them is like we want to expand the network, right? So as you can see from the map, the yellow rectangles showing our coverage area of the village that we went, but we want to extend the network to the red circle, but we could not do that. We tried many solutions with the Wi-Fi long range and also the multi-hop communications as well. As you can see, this is the real location on that village. They have it in the hillside surrounding by the mountains, and we have a lot of high tree. So this is complete non-life site. So we're looking around what could be the next solution for us to solve this kind of issue. And then we found that TOI space could be a good option for us. So the TOI space basically is a TV channel, TV spectrum that we know that this is a low frequency band, 400 VHF, USF, which is have a very good in terms of radio characteristic. So it could support a non-lopsided situation. And we can have the long distance propagation, communication 10 to 20 kilometers. And also nowadays, there are so many standardization available in the market and many vendors and many production proposed to use that one. And basically, most of the standardization also support point-to-point communications as well. So, but for the TY space, to use them, we can use them only if the spectrum is not being used by the primary user or the licensed user. In our case, it's a TV broadcasting. So basically, we have to identify that what kind of spectrum that we can use, and that one is showing the white space, and this one is occupied channels. So to do that, we get the general support from the NBTC, which is our Thai regulators, by funding us for the project, for the research project called TY Space. The project is running from 2020 and up to early next year, 2019. So the proposal project is try to do kind of exploring the benefit of the TY Space. So we hold, currently we hold a license from the whole band for the TV channel 470 to 790. And so this is going to be the first TY Space trial in Thailand as well. And apart from that, we need to carry out a lot of measurement to identify what kind of white space in the rural area. This is the main purpose of the project. So to start with, to start the project, so we first have to do a lot of measurement to identify the spectrum white space. And those is our equipment that we use at the moment. So we use the low-cost spectrum analyzer called IETF. The benefit of that, because it's cheap, we can buy a lot of them, and then we can give them to many volunteers like students to run the measurement in their home and in their house. And we're also using the small equipment like a laptop or a Raspberry Pi. And we also get help from ICTP in Trieste, Italy. He's our partner to develop the software to recording the spectrum measurement from the IETF and then record them in digital format in the Raspberry Pi. And here, this is our configuration for the measurement. So we are scanning the whole band from the TV channel in Thailand, 510 to 790. And the signal bandwidth is about 8 megahertz and bandwidth resolution. Yeah. So in terms of location, we are considering interesting in 2 different locations, like inside the building, indoor, and outside the building, outdoors. And we're also considering the height of antennas as well, like at the ground levels or at the rooftop, like 15 meters, 10 meters, and so on. So what's the problem? So now we have a bunch of data. So the next thing that we have to do, identify what kind of TY space. So the common method used in the literature, mostly we are using the fixed threshold, where we set up the threshold to identify the signal. For example, if the signal is larger than the threshold, we consider this is the channel is being used. FCC recommended the 100 minus 114 is the recommended threshold from the FCC, but in the literature, people say that this is quite conservative threshold, and then people prefer to use the 100. This is kind of rule of thumb number, and then people being used that one. And we also have another threshold called occupancy threshold. For example, if the signal is not being used more than 80%, we consider that this is a white space. So what happened with this method? This is showing the measurement from the same location with the same equipment. This is showing the channel from channel 26 to channel 60. You can see by eyes, because both of them have the same pattern. So the dark blue showing that spectrum the channel is free, it's not being used. But the problem is, from these 2 measurements, we found that with the fixed threshold method, the first measurement we identified that 10 channel is being used, but the second measurement showing that 14 channel is busy. So this is not quite accurate, right? Because as we know, from our measurement, we see that some sample is like got minus 101, but some sample is minus 99. But we consider this is free or not free. This is a problem. This is kind of dilemma. So we're looking around, and then we are deciding to use the adaptive threshold setting. We try many methods like NPs or FCME and RAT. This is from the old technique that used in the literature, and we also propose 2 new techniques as well, like adding some percentage of noise to improve the performance. And And this is happening here. The horizontal line here showing the fixed threshold, and the red line showing adaptive threshold that we see. As you can see, the adaptive is doing quite well because it's quite adapt regarding the signal that you receive. As we know, the spectrum that you can receive, they have many variants in terms of noise and spectrum diversity as well. So adaptive threshold should be better solution for that. So we recently we just published the work that we done here. If you are interested in, you can look into the paper. Our paper just published through ACM Compass early this year. So in terms of comparison, this is kind of we look into the parameter called false alarm detection and probability of false alarm and probability of misdetection. So from the false alarm mean the channel is free, but we decided the system showing that it's not free. That is false alarm. And on the right word side, it's called the misdetection, when the channel is not free, but we mentioned that it's free. Okay. The improvement is doing quite well. Like in terms of false alarm with adaptive threshold, we get about 0% of the false alarm, but with the misdetection, we can improve above about 60 to 70% compared to the fixed and the basic FCME algorithms. So we have compared the data measurement from the AT Compass, because in AT Compass we have a good ground truth from the regulator, because they have the report from the spectrum location in those areas. This is quite accurate and quite reliable. So we compare the results, and we're showing the benchmarking that our adaptive threshold could be good to do more benchmarking to another location. So next one. So from that technique, so we prove that, and then we apply the spectrum measurement with our technique to another location, which is in darknet, and this is our white space that we can use, which is, you can see that the many channel is free and we can use them. So okay, here. So utilizing them, as I mentioned, in darknet, we have the problem in terms of connectivity. So we have two solutions for that. The first solution, we're gonna use TY space for the backhauling, connect the remote village to the TY base station that deploy at the public school. We have internet gateway over there. The distance between the base station to the village is vary from 500 meters to up to 10 kilometers. So it should be fit to the TY space. The technology that we use, we're going to use a standardization 802.11af, which is called Super Wi-Fi as well. The second solution, we're looking to the access layer inside the village. So lately we have only wireless mesh, right? But we also expand using the TY space for the LTE small cell base station inside the village as well. So go first. So we decided to choose the equipment from off-the-shelf equipment available in the market called Carson Gen 3, and which is to support 802.11af. And we just got equipment recently last month, and we now try to test them up inside the campus to checking that, okay, the equipment is working properly and what kind of the design that we can make. So, and this is the diagram architecture that we set up. So we set up the pole about 7 meter high between the base station and the receiver side, and thumbs up. Okay, we do quite quick over there. Okay, and so the maximum distance we test, I think we just made it last week. It's about 1.2 kilometers, and this is the profile that we got. Like we got quite pretty good receive signal power. The throughput is about 10 megabit per second for uplink and downlink. Packet loss, we achieve almost 0% packet loss. TT is quite low. Okay. At the second solution, as I mentioned, we're also working on, in parallel, working with Microsoft Research UK as well to do the trial for the LTE using over the TY space. And this is equipment that we use and donate. It is given by the Microsoft Research UK. So that is our base station. That's antennas, SIM card, and also at the user side we have the MiFi, like a pocket Wi-Fi. So this is the network configuration. We have the FAB, which means the base station. The base station needs to talk to get the permission from the POL, which is the database, the white space database, to give a grant which spectrum that we can use. And we have a HTTP agent connect to the EPC, which is the mobile call software like MSC for the 2G. And unfortunately, since this is working with Microsoft, right, and then the cloud that we use in Microsoft Cloud, and unluckily, we don't have the Microsoft Cloud in Bangkok. The closest one is going to be in Singapore and Hong Kong. So we already do the trials almost 2 months already. So that is the base station. We put the antenna in the base station in the IT building of the campus. Is the height is about 12 meters, and this is the highest building that we can find in AIT in our campus. And you can see that surrounding is it have a lot of high tree over there, and it's completely non-line of sight situation. So, and this is a coverage area that we can find. We found that we get the coverage area about 500 meters, which is cover the part of the campus already. And then we do some testings as well, like we testing inside the lab, in my lab, and the distance from our lab to that base station is about 200 meters. And this is kind of we do just a simple speed test to see that, okay, what kind of the bandwidth, the latency that we have. And also we measure the spectrum as well. We did 2 types of testing, like we testing the server in Hong Kong, because at the time for testing, the EPC is located in Hong Kong. Choose a Hong Kong for the primary EPC. And we do the testing compared with the BKK. We found that for the Hong Kong server, the Hong Kong case is pretty much slightly better compared to the BK, because as we know, as the cloud is in Hong Kong, right? So you should get the better performance as well. But this is quite interesting because we want to deploy the system, the equipment in Tak Net, which is far away from Bangkok. So we might get the problem in terms of connectivities as well, because the EPC is in the cloud and then the cloud is outside the country. So this might be another new research dimension that we are focusing with as well. So so next step, actually, there are many steps. The first thing we want to deploy the system that we have, like the TUI space backhaul, and also the LTE small cell in the Tak Net, which is the northern part of Thailand. So we plan to do that maybe next month, at the earliest. And we also try to explore another method for the spectrum measurements as well, because we want to build by introducing like kind of machine learning neural network as well to better build the accurate data for the white space. And of course, we still keep expanding Tak Net in order to connect people as much as we can. So that's it, I think. And okay, sorry, this is our team for the Tak Net team. I have to mention that with the Professor Kajanai, this is the whole team that we're working together. And I would like to thank THNIX as well. Is our sponsor, is kind of our sponsor so far since the beginning of the project. And we have NBTC to give us the research grant and also the license. And we thank to ICTP to helping out for the spectrum measurement and device and so on. Those Cambridge and Microsoft Research UK for collaborating in terms of LTE solution. So that's it. Thank you so much. If you have any question.
Yeah, we've got time for a couple of questions. Does anyone have a question for Adisorn? The mics are in the middle of the room.
I had a question actually. If you go back to your slide where you had the kind of false positives,
yep.
You know, the slide, I mean, I'm just trying to make sure I understand it correctly, because it seemed like the left-hand side of the slide where you had got down to 0% probability of false alarm. I mean, that's great, but it seems like the occasional false alarm sort of doesn't really matter very much anyway.
That's true.
Whereas but what I want to say on the right-hand side, you've got an improvement there, but you're still never using the spectrum when it's otherwise occupied. And it seems to me that that's, if I'm understanding it correctly, that's kind of a problem.
Yeah, that's correct. Actually, the critical parameter could be here, the misdetection, because if you misdetect it, it means you try to interfere the primary user. So far, our statistics is not, it's just the best probability we get about 30%, which is still quite high. And we keep an eye on that as well, but because we try to introduce another new technique like machine learning or another kind of neural networks as well. This is like we are working. I'm working with another PhD students as well to try to improve this gap.
Thanks.
Thank you. Any other questions? Please go up to the microphone.
Oh, sorry, that previous question was Matt Ford, by the way. I didn't say my name.
Yeah, Emmanuel Bocelli, INRIA. Thanks a lot for this nice presentation. Seems like really great work. One question, like when you do your detection here, like you do it at one point only, right?
Sorry.
When you do this detection.
Detection? No, yeah. It's for one location.
Yeah, one location.
One location.
So do you think, because you're targeting like big distance, that it would make sense to do that and cross correlate on the, both on the sender and receiver? That would make sense?
Actually, okay. Actually, this one, the plot that we have here, just one particular location, but we have a bunch of them, not only one location. We have at the receiver, at the end size as well. Yeah, both sides. But I was mentioned that because we choose the location inside the campus because we have a good data from the regulator, because they have quite accurate data which spectrum is used or not, and we use them as a guide to compare to our measurement.
Hi, Stephen Farrell. Can you comment on the kind of costs and sustainability and how you might extend the technology to kind of more villages? Or maybe this is just a research network and that's not really relevant here, but if it is relevant, I'd be interested in what you think.
Oh, you mean the investment, or I didn't?
Yeah, a typical issue with these kind of networks is that you can build them and then the project ends and the funding goes away and they stop. But
yeah, that could be. I think for the equipment, it's not the big problem because we can give them to run and we still have the funding because we bought the equipment anyway. But the main problem is going to be the license, because now our license is going to be end by next year, and hopefully we could get extension and we do more trial to support those people. But we try to do this project as a pilot project and then try to convince our regulator, okay, this is a lot of benefit, a lot of impact that we can use the dose spectrum for another purpose, and might be from this project, it can be a new model that we can, like a local ISP run operating in the TY space to cover provide the low cost internet connectivity. This is our future plan.
Okay, great, thanks.
Thank you very much. And thank you for the questions. I think we're going to skip over to Lakshmi now.
Yeah.
Thank you, Adiswarn. And Adiswarn, you're here all week, is that right?
Yeah, we will.
Excellent.
Yep.
So if you have questions for Adiswarn, find him in the halls. And one thing that he was mentioning with respect to TV white space is that there's a big regulatory push on for some folks in 5G. They also want some of that TV white space. So the community networks that we work with are having a bit of a difficult time trying to convince regulators to let them use some of the TV white space. So it's been an interesting endeavor. Lakshmi, you're up. Can we turn over to you now for GAIA's networks?
Yeah, if you speak up, I think we can hear you.
Can you hear me better now?
Yeah, that sounds good.
Fantastic. Hello, everybody. Sorry if I got a little bit delayed to bootstrap the session. I was still trying to wade through the system to get the exact link up. So I'm very, very happy to present. So Jane, do I have my slides up?
You do.
Okay, awesome. How do I tell you to go to the next slide? Should I just say next slide?
Absolutely.
Awesome. Thank you. So it's a great pleasure to introduce to you all GAIA's networks. This is the very first time I believe we are giving this talk. And we owe a lot of gratitude to the GAIA community for the creation of our new startup, GAIA's networks. And it's been in stealth mode, and today is the first day we are declaring it open. GAIA's comes from the male version of GAIA, and we have a very shared vision with respect to all the goals that Gaia is trying to achieve, and we hope to work with the Gaia community to make both Gaia and Gaia's very successful. Slide number 2. Here's a brief description of the Gaia's Networks team. As you can see, the person in charge running the show is going to be Arjuna, going to play the CEO role. And we have a collection of 6 PhDs, one finally in the making through Talal. Yasser Zaki will play the CTO role. Thomas Poch will be in charge of products. Jay Chen will be the chief scientist. Yasser and Jay are faculty at NYU Abu Dhabi. I'm a professor at NYU in New York. It's been about 10 years of work put together that is leading to where we are with respect to Gaia's. Slide number 3. So what are we trying to do in Gaia's, right? So if you take mobile users today, the actual user experience in developing countries is really poor, right? Due to a variety of reasons. And operators really need much better solutions, especially for ubiquitous and ultra-fast access to content. And they also want a seamless user experience, even in conditions where the network environment can be challenged, right? And most importantly, they need a platform for enabling local content, right? There are many places around the world where servers are sitting in a developed country and there is very little local content generation, distribution, and consumption. And that's one of the core problems Gaia's aims to fix. And if you look at mobile web in challenged environments, in the next slide, slide number 4, it's actually not surprising to note server latencies like 2 to 3 seconds. We have seen scenarios where DNS sometimes takes 15 seconds to resolve through recursive DNS queries. And web pages with hundreds of objects and 30 to 40 connections can take over a minute sometimes to load. And sometimes it's not just the problem of network connectivity, it's just that the web is a mess, right? So if you want to really fix this problem, in Gaia's, in the next slide, slide number 5, we do 2 completely different things. First, we want to design a web where the content is really ultra lightweight. Can you design content that is 20 times smaller, 30 times smaller, 50 times smaller than the standard web page that you face today? We think JavaScript can be a curse. Can you actually design web pages with no JavaScript? And so one of the things we have done here is we have designed a new mobile app specification language and a lightweight content ad platform, which I'll talk about, which enables really ultra lightweight content. The second aspect from the networking side is, can we make content ubiquitous and really fast? So here we have a high performance mobile stack coupled with an edge cloud platform and a highly optimized content diffusion framework. Okay. In the next few slides, I will explain these concepts. Slide number 6. So this is Gaia's Networks in a nutshell, and there's a lot going on in this slide. So let's focus on the left side of the picture, right? You see 2 buzzwords, local content providers and local ad providers, right? So the core product offering of Gaia's is basically a mobile edge cloud platform, right? Which can sit as close to the base station or as close to a collection of base stations, like close to an S gateway, for example. And a locality is at the granularity of something like a city, right? Think about something that has 500,000 users, anywhere between 10,000 users to 500,000 users, right? So what we want to do is we want to have a Gaia's app that people use, right? Which is basically a Gaia's browser. And we want to have intermixing of content from local content providers and local ad providers. So content is going to be viewed in the concept of channels and is going to automatically get intermixed with ads on the fly to present content as channels to the end user using a Gaia's app. Now, the whole platform can be replicated across multiple edges. So you would have a decentralized edge abstraction, right? And you could also have global content providers like the Googles and the Facebooks participating across individual edges, almost like in individual localities. Okay, slide number 7, expanding upon this a little bit more. So what we are trying to do is essentially create a content ad marketplace where you have content providers having small cloudlets, right? And the cloudlets essentially hosting content of a content provider, right? And when somebody clicks a particular content on a mobile phone, right, through the app, each content request is going to, in essence, create an auction, a content ad auction, where the ad auction is going to run on the edge and the right ad is going to fill in into the right content. Now, unlike a traditional ad exchange, here the ad exchange is controlled by the edge. And what we want to essentially look for is local ad providers. Let's say I'm producing milk and I'm distributing milk in Rwanda, right? Do I ever even get an opportunity to advertise in any place? I barely get any opportunities, right? Maybe local radio. If you have a platform like this, I want to enable that milk producer to be a potential content ad provider who could pay a small amount of money and get advertised as part of local channels.
Lakshmi, are you there? I think his mic went out. Yeah, is he frozen? Lakshmi, you may want to turn the video off to save on the bandwidth there. We might be able to get you back. A meet echo issue.
He's left Java with him as well, so that suggests it's his connectivity.
I think it's his end, actually. Meet echo was doing quite a good job earlier connecting with folks.
Sorry, can you guys hear me right now?
We can, thank you.
Awesome. So I'm in slide number 7. So I talked about the content ad exchange. That's the core product offering. So it's a mobile app with a content ad exchange running on the edge. So slide number 8, I'll go through it a little bit briefly. Essentially, what runs on an app is this layered stack where we can take a traditional TCP, TLS encrypted framework and run our own congestion control called ALCC on top. And we have the specification language called MAML. And this browser can basically handle MAML content and show MAML content on a phone. So it's almost like a MAML browser, where MAML stands for Mobile App Markup Language. And ALCC is an efficient protocol that I'll probably very briefly get to at the very end. So slide number 9, a brief description of MAML. So MAML is a relatively trivial concept, but it can appear a little bit complicated. Okay, so think about a web page, right? Think about a web page as a rectangle or a collection of several rectangles, where each rectangle is basically an object, right? So given a web page, can I basically pre-compile the whole web page such that I completely flatten out a DOM structure, right? And create a new web page which has no recursive request, no JavaScript, and each object has a very basic set of primitives, including the ability to refresh, right? So my claim is you can create a web page that is basically having the same look and feel as the original page without any JavaScript, but basically gives you the same look and feel and is 20 times smaller. So slide number 10. Here's an example of two such pages. So if you look at the two pages on the right, they are the pictures of the NIH webpage. And on the left, you have a picture of one of the news sites, right? And the left one is actually a mammal page. And if you take the NIH pages, the one in the middle is the actual NIH page, and the one on the right is the mammal page that we create. So if you do care about look and feel, we can generate at a very fine granularity a page that has the same look and feel, but the page on the right is significantly smaller. Okay? Now, how do people think about this, right? So we compared Mammal with Opera Mini and Chrome, and we showed that it loads much faster and its size is significantly smaller compared to even Opera Mini, right? And we compared it with different fidelity levels. So our app has the ability to change the fidelity level, where Mammal low means very low fidelity and Mammal high means full fidelity level, right? So there are scenarios where Opera Mini pages in the extreme cases are actually slightly smaller when you maintain high fidelity levels, right? But Opera Mini does take much longer time to load, even if sometimes the page might appear smaller, because Opera Mini has to go through recursive DNS requests and recursive downloads, but Mammal is a straight one-shot download of a web page. And the second thing is we ran a user study across hundreds of users, and we showed that 80 to 90% of people who looked at Mammal pages found that it was very similar to the original page, while 10 to 20% felt it was similar. Very few people said it had little similarity to the original page, right? And going on to slide number 12, talking a little bit of the content ad platform. Essentially, it's, as I mentioned, it's running an ad auction, and we can take different types of ads. We can take video ads, audio ads, image ads, and so on. And we can change the fidelity of the ads. And we can also have ads that can, the same ad that can be represented over an IVR call or an SMS, or the same ad that is represented as a full video ad for a particular web page. So we specifically ask ad providers to give ads at different fidelity levels, and we can tune the type of ad that gets displayed on the fly as a function of the user bandwidth and preferences and the content provider's preferences. Okay, so the ad platform is compatible across different types of content. Now, to give you slide number 14, to give you a brief purview of the high performance stack, we have designed a congestion control algorithm called ALCC, which builds upon our earlier work called Verus, where we have basically been able to show that we can design a congestion control protocol for cellular, where we have a 1/15th reduction in delay while maintaining the same throughput as TCP cubic over a cellular link. And this has been widely tested across a lot of cellular networks. We wrote a SIGCOMM paper about it, and then we have a follow-up paper at Usenix ATC as a short paper. And we're building upon it to make it into like a full-fledged application layer congestion control stack. So our mobile platform, between the mobile app and the edge, can basically run ALCC and can guarantee you very high performance and with very low delay characteristics. Like a 15 times reduction in delay is a pretty big deal. And TCP cubic does a really bad job, especially in cellular networks, to bloat up buffers, right? And this actually significantly increases the user experience for audio, video, AR, VR, and other types of things, right? Slide number 15, before I conclude, we also have a distributed content diffusion framework called Xcache, which allows you to smartly move content to the edges in a sort of a decentralized manner and manage these edge caches in an interesting manner, so that we can have live content close to the edges as quickly as possible. And this distributed caching solution performs better than traditional caching solutions that have been proposed in the architecture. And we have compared it with legacy caching solutions and have shown between a 2x and a 5x gain because of this distributed caching system. So Gaius is trying to put all these pieces together to design a really fast, lightweight web, and is specifically targeting emerging markets. But the core crux of the proposition is to enable localized content and localized ads to create a sustainable ecosystem in each city to be able to run a decentralized web. With that, let me stop here and take questions. Thank you very much.
Thank you very much, Lakshmi. Does anyone have a question for Lakshmi about Gaius in the room? Okay, we do have a question for you in the room. Is there anyone online that has a question? If you're in the Jabber room.
Hi, Lakshmi. I'm Addison from AIT. So I have a question about the content. So the memos browser is going to be applied for the all websites or not? Like when the user turn on the memo and access to the website, the content will be transformed from the memos, right?
So great question. Let me answer that in two parts. So MAML is not designed to change the full web. So on one side, MAML is used as a standard within Gaius to enable people to create lightweight MAML pages. Okay. The second part of the answer is people who really feel that they want to maintain the look and feel of a traditional web page, right? We have gone through the extra mile to say that we've played around with 50 to 100 websites, and we have been able to show that we can automatically convert a variety of existing web pages to have the same look and feel using MAML. And we have been able to support dynamic objects, we have been able to support forms, and we have been able to support refreshing of content and so on. So we've been able to support most of the basic primitives, including audio, video, and so on, as part of MAML. And it's mostly centered around the idea of pre-compiling a web page rather than having recursion and JavaScript to be. So MAML does not allow very detailed analytics type of requests that some traditional web pages might have, where you can move your cursor and you can track your cursor about certain things. So it does have certain limitations, but it's primarily designed for Gaius pages. Does that answer your question, Addison?
That's great. Actually, you answered my next question, because I'm gonna ask about how the compatibility with the local webs, the existing content. But I still have another question. Like, what about the copyright? Because if you're gonna, because basically you're gonna cache all of them and then retransform.
Great question. Great question. So as part of Gaius, when it's running as a network, content providers will have the ability to choose whether they want to be part of Gaius or not, right? And content providers will have, so if some content provider doesn't want to be part of Gaius, then that content provider will not be available as a channel.
I see.
So in some sense, the content provider has to, opt in to be part of Gaius to make that type of content visible within the Gaius ecosystem. And Gaius is primarily designed for localized content. So any user can start creating content. So you have a chicken and egg problem of how you bootstrap the system, right? So one way to bootstrap the system is to get local popular content channels to participate as part of the Gaius ecosystem. So you want to start with a city granularity where the content providers first decide, okay, I want to be part of the Gaius ecosystem, to make it interesting. And then you can have people participating, creating their own channels on top, and you can have this mixed ecosystem on top.
All right. Yeah, you already answered my question. Yeah, thank you.
Thank you.
Excellent. Are there any other questions for Lakshmi? Thank you, Lakshmi. This looks like a really interesting solution for a lot of developing countries with low bandwidth.
Thank you very much, Jane, and everyone who helped in organizing this.
Super appreciate it. Up next is Shadi, who's with the Alliance for an Affordable Internet. Shadi, can you say something so we know that you're on the...
Can you hear me?
We can.
Is it any better?
It is, and we do need you to make sure you don't touch the microphone too much, but otherwise you are coming in loud and clear.
Okay.
Go ahead.
Thank you, Jane. Thank you everyone. Thank you, Gaia community, for this opportunity to A for AI, the Alliance for Affordable Internet, which is hosted by the Web Foundation, but partnered by a number of entities, including folks like the Swedish government, the US government, the UK government, and also our host governments such as Myanmar, Bangladesh, Nigeria, Ghana, Kenya, and so on. You may have heard Sir Tim Berners-Lee making this announcement, the contract for the web, yesterday at Lisbon, and we are very proud that our founder, Sir Tim Berners-Lee, is again leading an initiative that calls for a decentralized web, something Lakshmi just now elicited very beautifully. I'm presenting this very brief 10-minute presentation without a PowerPoint presentation as well as a video stream. And also I must admit here that my presentation is not about any technological or engineering solution, such as the last two presentations, the TV white space one by AIT and the Gaia's solution for local content and local content ad streaming by Lakshmi. Whereas I'm going to focus more on the policy interventions that are required to make a web that is universally accessible, also by the 60% bottom percentile income percentile groups within countries, but also the regulatory measures that could be undertaken to ensure that this could happen. And in this, I'm going to also touch base upon the age-old solution, which is the Universal Service Access Fund, which was introduced a few decades ago, a globally tried and tested mechanism to spur ICT investment in underserved and unserved areas. So I'm going to talk about that as well. Now, on contrary to many people who don't like to have this levy, the Universal Service Access fees, which is contributed largely by the telcos, mainly to extend coverage in rural areas where the market fails. Many people have done their research and come to a conclusion that universal access funds don't really work well. While we take note of that, we suggest that this window of opportunity should be kept as one of the many solutions to ensure that universal service is achieved as much for the rich, also for the poor. And in this context, we also want to highlight the need for spreading the web among special interest groups, particularly women entrepreneurs, and other marginalized groups such as the disabled and the elderly and so on, so that the web can be a web for everyone rather than the web for only the top 40 percentile income group. See, the 1 for 2 campaign, which most of you may be familiar with, which is run by the Alliance for Affordable Internet, also adopted by the Broadband Commission, talks about 1% of per capita income, not more than 1% of per capita income to be spent on 2 GB data access. But if you look at the latest affordability report, take for instance the Asia Pacific continent has actually achieved 1 for 2 target. Would that mean that Asia Pacific, we don't have to have any local content or connectivity solutions? The answer is no, because although the 1 for 2 target is met, when we dig deeper and analyze the data as to who accesses the web, we do come to recognize that the top 40 percentile income group only have access, and the internet is not affordable to the bottom 60 percentile in many cases. And in the case of Myanmar, for instance, a country which is long ago achieved with 4G connectivity at the fore, we still do find that people not taking advantage of broadband. So that said, I want to also mention a recent report that we released in Africa, that was in May this year, which categorically shows that amongst the countries that we surveyed, 37 African countries do have a USAF setup, but only 62% of these funds are active. That means a good number of countries are not utilizing this fund, and there is an unspent fund of total estimated $500 million available in Africa, which could be spent in multiple solutions, including the solutions that the 2 solutions that were demonstrated just now, the TV white space and the local content solution. But we also want to take note of the need for spending on women, bringing women online. So the 408 million, which is unspent in Africa, we believe can be good enough to bring 6 million women online and provide 16 million women with the digital skills, women and girls with digital skills, and also a good mechanism for us to spend the money that has been collected sitting idle. Although in many countries we have seen certain steps undertaken, including countries such as India, Colombia, Benin, Ghana, and so on, we do see that there is an ample opportunity for us to utilize these funds to bring women online. We also take note of another policy opportunity, which is increasing public access amongst the underserved and unserved communities. We believe that the USAF can be utilized to increase public access, not just as a connectivity solution, but also as a solution to provide e-government services, to local content delivery, to participation by local entrepreneurs, something similar to what GAIAS is trying to do. And there are a number of such experiments, and I've been a part of personally an experiment called the Open Knowledge Network about 14 years ago, which was a local content delivery platform that we built when the web was in a very primitive stage, using world space, radio, and other technologies to push and pull content. But many of these remained as experiments until now because of the lack of policy and financial support rendered to these kinds of networks that have come into play. So in conclusion, what I want to highlight here is if the Universal Service Access funds are spent properly with right people on the board in a transparent manner, with more and more multi-stakeholder involved in the administration of the fund, there is an opportunity for us, so that the funds are not just spent in very high expensive technological solutions, but also to develop the ecosystem at the underserved and unserved areas. And I'm also glad to note that the next presenter is going to talk about the community networks, where the community take charge and control of their own ability to exploit the web as a solution, particularly the rural women entrepreneurs and their experiments in Maharashtra in India is a good case in point. I can mention briefly about the 3 or 4 good examples that we have taken note of in the latest report that we have released on affordability. The Ghana GFEG has invested in the Digital for Inclusion programs, which among other things looks at 60% of all local agents, local content agent and local digital payment agents as women. In Benin, we have ABSU CEP program that supports women, rural women entrepreneurs with mobile phone-based system that provides a price of local agriculture goods, such as corn, millet, soybean, and peanuts, and so on, because these are all sellers who need to know the latest price so that they can bargain a good deal. In Costa Rica, we have seen good examples of women actually in the female-headed households where mobile access is promoted, and they become really entrepreneurs in distributing services. So I would like to stop here by also highlighting Botswana and Thailand as a good practice when it comes to public Wi-Fi hotspots, public access internet. In India, you have more than 200,000 common service centers. USAF utilized in expanding the broadband network through the Broadband Limited, the state-funded company. In Botswana, we see a number of sites connected through Wi-Fi hotspots, such as hospitals, bus stops, taxi ranks, and so on. So I want to utilize this opportunity to emphasize that in addition to the local connectivity content technological solutions, we also need to advocate for policy and regulatory interventions that enable us to utilize the windows of opportunities such as the Universal Service Obligation Funds to not only provide connectivity solutions, but to grow the ecosystem in rural areas so that we do not have failures of our pilots, but successes of our scale-ups. Thank you.
Thank you, Shadi. Does anyone have any questions for Shadi? This Universal Service Fund issue is a big deal in most countries. It's quite corrupt in some, where the funds have come from the incumbents and mostly fixed and mobile operators. And the regulators have a hard time getting that money out. As Shadi is saying, in Africa alone, you've got over $400 million sitting in different regulatory accounts that could help support internet exchange points, community networks, and other. And so folks like A4AI, we're taking a small look at it, but really A4AI has done a great job on this, as has the Association for Progressive Communications, where we keep promoting with people we work with, not only in the technical side, that you need this policy-related aspect pushed. So Shadi, thank you very much. We appreciate it. This was much appreciated that you did this on short notice as well. So any other questions for Shadi? If not, we're gonna move over to Sharbani, who's coming from Mumbai, and she works at a university there. She'll briefly introduce herself. She's another partner of many of ours on connectivity, local connectivity in villages, and also tech options that they're taking a look at. So Sharbani, could you quickly introduce yourself and we'll pull up your presentation. Sharbani, are you ready? We're ready for you.
Hello?
Yes, can you speak up, Sharbani?
Yes. Hello, I'm Sharbani from Grammarg at the Indian Institute of Technology, Bombay, and I work here as a senior project research scientist. In one of the IETFs, I have actually presented about what Grammarg is. Working ahead on the projects that we are taking forth rural connectivity. to the remote and unserved villages of India. We are now, today I'm going to present to you about connecting villages, the role of village administration. This is not any technology intervention, but it is an intervention for policy measures that these remote villages should be connected, and the role is of the village administration itself. Next slide. If you look at the objectives, the objective is that till now 75% of rural India is still unconnected. Some of it doesn't even have voice connectivity. And the government of India is really trying hard to connect these villages through the Bharat Broadband Nigam Limited, that is a BBNL, which is laying optical fiber for connecting the Gram Panchayats. That is one of the locations where the connectivity goes from the telephone exchanges. That's where it goes. Gram Panchayat is sort of the head village, and it has 3 to 4 villages along with it. The government also has an agenda that, if you look into the agenda of the BharatNet, is that the government has an agenda only connect the Gram Panchayats, but not the villages. And that's a really sad part of the story, that eventually, even if the Gram Panchayats are connected, the villages in India can never get connected. And what is the status of these villages? Some of these villages are remote and unserved villages, and these remote and unserved villages actually will not get connectivity for a longer duration of time. They even are not connected through private telecom operators or through fiber. So these the probability that these villages will remain unconnected for a longer duration of time is even higher than even the villages that are very close by to the highway or close by to the cities. The next slide. So a little bit about BharatNet. That is, BharatNet is a project of Government of India, and it is a digital plan set up by the Government of India to connect 250,000 Gram Panchayats by broadband internet connectivity. The project is going very slow. And just the first phase of the project is over, where they have connected almost 125,000 GPs, the Gram Panchayats, but there is still a lot that needs to be connected. So it is in total 250,000 Gram Panchayats that need to be connected. So there is a decision now taken by the government that 125,000 remaining GPs can be connected on an optimal mix of solutions like fiber, radio, and satellite. And as an interim measure, while the fiber is being laid. So it's like radio and satellite are the other options that the government has taken up. The agenda is that 250,000 Gram Panchayats need to be connected before the next election. So it's like 2019 March has been set as a cutoff date for connecting entire rural India. So next slide. So going with this, we have looked into what is the current connectivity requirements in rural India, and we have done this that we have seen that less than so it is only if you look into the pie chart, we have done the calculation based on the population size of the villages and contention ratio of 1:25. Throughput requirement of the Gram Panchayats can be calculated as such, and you can see that many of the Gram Panchayats, most of it is like they require less than 40 Mbps throughput, and we are taking only those villages. The village administration should look into those villages where it is less than 20 Mbps bandwidth, because that comes into the financial scheme of the village administration. I'll explain it to you a little later. So we are concentrating only on those villages that have less than 20 Mbps bandwidth requirement, and the throughput requirement. And actually these villages are completely remote villages. Some of these are like tribal blocks or tribal villages. They don't even have a road to travel to reach there. The next slide. So, so the architecture that we are using here is that we take two options here. If you look into the left hand side, we look into an option of telecom towers that are at a location of 5 kilometers in the vicinity of the villages, or a connected GP. So as you see that the government has already enabled the first phase of connecting the Gram Panchayats. So we take two options. One is the telecom operator star in the vicinity of 5 to 8 kilometers. Here I have taken as 5 kilometers, and or a connected GP. So a connected GP, and from there they take the connectivity on 5.8 gigahertz unlicensed band to the other Gram Panchayats or the other villages that are not connected. Next slide. So we have been working on the remote villages in these remote villages that even don't have any voice and data connectivity. Why do these remote villages need the connectivity? These villages are
Hi, Sharbani, we may need you to reboot. Are you there? And you may want to turn off your video. Sharbani? Okay, you're back, yeah? We can't hear you, so we see you around Jabber. This is proof and point as to why we're doing all these projects. Can you see it? Can you hear us, Sharbani? All right, we may skip to the next presentation. Arzak, are you there and ready? Okay, Sharbani, we're going to skip to Arzak for now, and we'll come back to you. Sorry.
Yeah. You can hear me now?
Yes, we can. Can you just try and speak up a little?
Yeah, okay. Okay, so, yeah, so should I speak now?
Yes, please.
Yeah. So why do these remote villages need the connectivity? These villages are completely unserved. There are no, so there is a presence of telecom tower, private telecom tower, or private telecom operators over there, like Reliance Jio, Vodafone, Idea, Airtel, and others. But they don't serve the population over there. This is mainly because they don't get the annual revenue per user back from the subscribers. So what happens is that all the official work is taken to the cyber cafe in the city, and which a lot of time and money is spent because they take it to the city, and they don't get a reimbursement of it. So the village administration actually spends the money out of their own pocket. So the quality of work gets affected. Now, when the quality of work gets affected, so some of the villagers don't even have their iCards, like the Aadhaar card, which is a mandatory thing. They don't even have a voter card, and they cannot. So they themselves go to the villages. So the e-governance services that the government has actually framed for the villagers, made for the villagers over there in these remote areas, cannot be accessed by them. The next slide. So, so why the village administration? Now, the village administration is a very necessary partner in this model for taking the connectivity to the remote and unserved locations, and it is an integral part of seeding the growth of community network in these remote villages. So, the growth otherwise the growth of community network in these villages is not going to be that easy if the village administration doesn't take responsibility of the network. And to take responsibility of the network, they really need to they really need to own the network. So this is one of the reasons why the village administration needs to be an integral or a important stakeholder in this approach. Also the sustainability of the network. The sustainability of the network can only be managed because if the village administration take the responsibility, because the village administration has the authority and the finance, they have the capability to finance for the network in these villages. So we have worked on with them. And the community also, when the village administration takes a responsibility, the community also feels very secured, and they feel that yes, they should also be a part of the community, of the network. And of course, the security and longevity of the devices in these villages where the administration takes over the network is for a longer duration. It's long. There are no devices that are stolen. People take care of the devices and things of that sort. The next slide. So how the village administration can be involved in the connectivity process. So we work together with the village administration, and we are currently in the process of developing this as a policy intervention, that connectivity is needed both by the villagers as well as the Gram Panchayat office, the village administration. There is a need for low-heighted towers at the Gram Panchayat office. The village administration, 15 meters, less than 15 meters, and use of alternate power supplies such as solar panel should be employed. So these are places where the village administration can fund for these from their fund that comes from the state government, and pay for 2 Mbps bandwidth monthly from the local ISP. The local ISP is ready to, we have channelized the local ISP and we have got them in touch with the village administration, where they can pay for the village administration can pay for the bandwidth. So the next slide. So here, what is happening is that in our villages, so these are some of the towers that has been set up at the location, that is at the village location, at the Gram Panchayat location, and you can see the solar panel and the devices that are put up on the tower. The next slide. This is a partnership model that has been developed by us. We have identified the important partners, and Panchayat, that is a village administration, is an important plays an important role in this partnership model. And this is the reason why, based on this model, we have actually discussed with the village administration to start funding for the connectivity in their own villages. So this is the public-private Panchayat partnership model that we have developed, and this is a sustainable model on field, which has been validated on field, and it is a sustainable model. The next slide. Now, each of these villages each of the villages in India have a 5-year financial plan that they need to put it up to the village, to the district administration or the state administration, and funds start flowing from the state administration. In this, we have identified that there is a flaw, that there are street lights, putting up street lights, water taps, road connectivity, everything, but there is no internet for development. Now, internet for development, if it is included in this financial plan, this is a 5-year financial plan. Most of the connectivity can be taken up by the village administration, and it can be funded by the village administration and owned by the village administration. The next slide. So internet for development needs to be included, and we have worked out on a government expenditure, because the government, to show it to the government, we really want to include. So only the first year there is going to be a capex involved with the bandwidth charges for 6 months, and from the next year onward, it is going to be very minuscule amount of OPEX that needs to be generated, that the village administration needs to pay. So only the first year is going to take a chunk of the money for putting up the tower with solar batteries, solar panels, and solar battery backup. And based on this, we have also worked out on a per user village cost. So it is roughly around 120 to 150 INR. That is around $1.5. Roughly around $1.5 per user per village cost. So if the village wants that the OPEX has to be generated from the village by the utilization of the services in the village, then they can charge the people around $1.5 and generate the operational expenses. We are also using, some of the costs can come down if we use like defunctional towers that are already located in the village premises, the office, village administration office, and that way the cost can also come down drastically. Next slide. Now we have deployed our connectivity in 25 villages, and we have tested the sustainable model in two different parts. In 15 villages, we have tested the model that the connectivity reaches the village administration, and from there the local ISP uses a marketing strategy by which he sells the bandwidth inside the village. And we have done a cost-benefit analysis of it, and you can see that in the cost-benefit analysis that actually it is sustainable from year 2. So from year 2, and you can see the blue line that the bandwidth increases. Just a moment. The bandwidth increases, and the need for bandwidth increases, and this actually is being monitored by the local ISP, and the local ISP sells the bandwidth. And as soon as the local ISP starts to earn a profit, this is with the data that we already have from the field, live data. So as soon as the local ISP attains sustainability, the return on investment is there. There is an reinvestment again by the local ISP, and that's how. So the blue line says that the bandwidth that is required, and the ROI is scaled up. In the next slide, if you can see the next slide, we have seen that how can this sustainability, we have done a predictive modeling for 5 years, and we see that the model can be, the return on investment is sustainable. It keeps on increasing year after year, and as the sustainability, as the return on investment increases, there's a steady return on investment. The bandwidth available, made available by the local ISP also increases, so that he makes a profit, and then he gets in more bandwidth. Now, if you look into year 4, almost the bandwidth is stable over there, because most of the users in these villages become returning users. That means they are fixed users, paying a particular amount every month. Next slide. In the other model that we have looked at is the VLE, the village level entrepreneur. So a local youth in the village is nominated as an entrepreneur, and then the local youth sells the bandwidth in the village, and the bandwidth is purchased in bulk by CSE, e-Governance India service that just now Shadi was talking about. So here you can see that the bulk bandwidth that is purchased is 30 Mbps of bulk bandwidth, and how the ROI is. So again, from year 2, it increases. There is a steady return on investment, and bandwidth increases, and the bandwidth is made available accordingly. A 5-year predictive model in the next slide says that you can see that it is how the sustainability, how the model is sustainable from year 2. So it is actually negative till year 2, but from year 2 onwards, it actually catches up, and there is the bandwidth requirement and the availability is almost at par with each other. This is all about my presentation. Thank you.
Thank you, Sharbani. Does anyone have any questions for Sharbani? Remember, some of the areas they're in are super remote, not wealthy. And the issue of being sustainable, and her predictive model is quite important to the deployment of infrastructure and working with the government. Thank you, Sharbani. It was so great that no one has any questions for you, but email. And what we can do is make it available if you don't mind. Is that okay with you?
Yes, sure.
You just had to ask for privacy reasons.
No, it's fine.
Thank you. And Sharbani is a good partner of ours in the field, and we are very keen to see how things are going with her. Thank you very much. And as you can see, we've done a reverse sun chaser event. We started off in Arizona and then came back here to Thailand. We've now hit India. Now we're up for Pakistan. So Arzak, are you with us? Arzak.
Hello. Can you hear me?
We can.
Hi, everyone.
Can you give everyone a brief introduction of who you are, Arzak?
Yeah, my name is Arzak, and I'm founder and director at Internet Policy Observatory, Pakistan. We were founded in 2014 to fulfill the gap between academia, policymakers, advocacy groups, and the telco industry. We are conducting policy research on ICTs in collaboration with some of the leading institutes globally. And we are also playing an active role on issues like net neutrality in Pakistan, the recent cybercrime legislation, and increasing access, which we have taken up greatly, along with providing tactical operations during disasters. I am grateful for the Gaia community, and especially thank you, Jane, for inviting me and giving me this opportunity to present about our initiative. And this is probably the first time that we will be talking about this initiative globally. Can you move on to the next slide? Internet Policy Observatory is basically a spin-off at Internet Policy Observatory based at Center for Global Communications Studies, University of Pennsylvania. We started by conducting joint policy research on the impact of ICTs in developing countries like Pakistan, and more precisely, what is the user response on issues like net neutrality, cybercrime, and recently cybersecurity. We are also working on increasing access to the internet in communities that have been unserved and remotely served by telecos. Can you move on to the next slide, please? Close the Digital Gap is one of the initiatives at the observatory where we aim to provide internet connectivity to remote communities in Pakistan. As you are well aware, that importance of connected citizen is very important for the information society. As a tool for human development and empowerment, ICTs have no equal, and this is what was the aim of our project, that is Close the Digital Gap. Can you move on to the next slide, please? So how it started, basically school children in some part of Pakistan, that is Balochistan, is almost one of the remotest and least populated areas, started protesting against telecos for not providing them with internet and voice communication. Because we were working mostly on policy issues surrounding the internet, we were alarmed by this development that the school children you see in the pictures were chanting banners and slogans for getting computer and internet access, and we decided why not give it a shot and see how we can provide them internet and computer facilities and maybe help them by contributing to becoming an internet society and provide affordable internet. Can you move on to the next slide, please? The pictures you see are the school children in various parts of the province of Balochistan demanding for internet access. Because of poverty, literacy, and lack of computer literacy, access to internet remains a challenge for them. And can you move on to the next slide? This is the map of Balochistan, which is Pakistan's largest province in the northwest, bordering the areas of Afghanistan, Iran, and the Arabian Sea. It is one of the most challenging areas in the country, with dispersed populations and making the telecos business case a very challenging one, especially when it comes to deployment of internet 3G, 4G solution. Can you move on to the next slide? The terrain is very challenging as well, and it's very difficult to access without many highways. The security situation is volatile, especially with the local insurgency and the insurgency with the bordering areas of Afghanistan and Talibanization. It was an extremely challenging project for the observatory, especially tackling these challenges of accesses in remote areas. And one of the other challenges that we faced during this project was electricity. Can you move on to the next slide, please? As you can see, this is a graph we made after conducting a study on the availability of electricity in most part of the province. Since most of the developing countries are faced with this dilemma of electricity shortage, we in Balochistan, where we wanted to initiate this Close the Digital Gap project, also faced this issue where there was no electricity for more than 20 to 22 hours in a day. As you can see in the graph, majority of the areas have very limited access to electricity, making our work more challenging, and identifying these issues was a challenge. The team, after gathering these statistics, especially on energy availability and access to telecos and availability of internet, proposed with the solution of setting up internet gidans. Can you move on to the next slide? Internet gidans are basically houses made of straw and mud, and gidan is a Balochi word. Balochi is a local language here, and because we do have a lot of these gidan houses in remote areas, in the remote villages where people come for tea, they come to discuss their local issues, they come to access issues regarding identity, citizenship, and other e-governance services. So we decided to come up with a different design. Can you move on to the next slide, please? The idea was to come up with a different way of thinking and doing things. Instead of going and following up the traditional way of doing things, that was to push USF for rolling out fiber networks and punish those telecos which were unable to serve in the areas. But we were witnessing that this issue was lingering on for quite a while, and there was very little change in the community, especially when it came to internet access. Broadband speeds were suffering, and the quality of broadband access was very poor as well. So it won't be a surprise if you see me going off during the presentation. So our team decided to come up with a different proposal. And the next, can you move on to the next slide, please? One of the team members suggested of mounting a VSAT on a traditional rickshaw. You might have seen a better version of this in Thailand, since you all are there. This was one of the suggestions, that we mount VSAT antennas and move them to the remote rural areas, but given the infrastructure and road condition, the idea was rejected. The next proposal was to probably roll out. Can you move on to the next slide, please? The idea was to roll out fiber networks, but rolling out fiber networks, as we have seen, is very costly, given the right to access ways and pathways and securing permission from the municipal committee. So we were balancing out various technologies and tools we can use for providing access to the internet. Can you move on to the next slide, please? So the value equation of connectivity was getting pretty confusing, especially when it comes to remote and rural areas and providing them an opportunity to participate and interact globally. The technology to be used has to be robust and sustainable economically and security-wise as well. It has to be accessible, since most of the population that we are dealing do not have the computer literacy in English language. So language was one of the barriers as well. And the tools and services, how we can train them on using those tools and services. And most importantly, what is community participation? It was very important for us that the community that we were working for participated and interacted and created content in the local language and ensured that these networks that we were developing remain sustainable. Otherwise, we have seen that community networks where communities do not participate or take ownership usually die out with the passage of time. So we approached the local community in most of the areas where there was no internet, and luckily with the help of civil administration we were able to secure buildings that were left out by various government offices ceasing operation those areas. We started connecting with donors in Pakistan who could donate us with computer equipments, laptop, mobile phones, or any other connectivity devices that we could use for setting up internet in those villages areas. Luckily, there were few telecoms that donated us old and equipment that they replaced that were functional and working. Can you move on to the next slide, please? This is one of the community halls that we are setting up. As you can see, one of the team members is laying out the LAN networks and doing electrification in the area. We planted solar panels on the rooftop of this building. So we have consistent supply of electricity, and we mounted these buildings with VSAT connections. And from those VSAT links, we furthered our networks using outdoor Wi-Fi to the community networks as well. But initially the idea was to set up the community halls and provide access and training to internet to these communities. But with the passage of time, we observed that female population, which do have limitations in traveling to public spaces in these areas, like in some part of India as well, because of the strict traditional tribal culture and religious norms being set, they were unable to join these areas. So we decided that why do not we donate them tabs and internet devices and provide outdoor Wi-Fi coverage to the villages by extending the fiber networks that would be able to provide them with internet access at their homes. And when that happened, the take-up was really impressive. Can you move on to the next slide, please? This is basically a DVP VSAT receiver that we plant along with the computer device. So whenever they have to use these devices, they can come and switch it on because it's not operational 24/7 of the day. We keep this operational from 9 in the morning till 5 in the evening, depending upon the usage. If the community is willing to use, like in some of the places, they use it till late night as well. Can you move on to the next slide? This is an outdoor VSAT terminal that we deploy at these local communities to connect to the internet, since we do not have any fiber networks or access to telecoms. As you can see in the next slide, that most telecoms that were offering voice or whatever data services decided to wind up their operations in these parts of the provinces, and all we can see is these left out towers that are lying there without any access to voice or video services. So we tried to contact the owners of these towers. Maybe they could lease us these towers so we could deploy radio networks. Some of the operators were helping us. They offered the use of tower free of cost, while others were reluctant to give it to us, even though you can see the picture that we had to mount our own tower while there was a traditional tower available with the antenna. Can you move on to the next slide? In the past 2 years, we have achieved a lot in terms of providing internet access. We established 26 internet gidans across remote and rural areas of Balochistan, which is almost 26 districts in the province. We also provide quarterly internet training programs at these gidans across Balochistan, where both male and female community members can participate. And most importantly, access to internet is free for all the community users. We do not charge them for getting access to this connector. What we are doing is we are collecting funds from donors who are funding us in the form of providing internet access by providing us equipment. PTCL, which is one of the largest telco providers in the Pakistan, has very generously provided us with the internet bandwidth. And importantly, with the use of outdoor Wi-Fi connected to the fiber network, we have seen the increasing uptake of female users in these communities, which is very important. Can you move on to the next slide, please? When taking up such projects, especially related to community networks, the challenges are immense. The lack of support from the government is one. The lack of international support as well. Recently, due to the government crackdown on international NGOs, getting support from international NGOs has been really problematic for us here. Lack of resources. We do not have further resources. We have probably more than 150 requests for setting up more internet GIDAs in remote and rural areas of Pakistan, but we do not have the resources in setting up these internet GIDAs. Unavailability of basic infrastructure like power is a major hurdle. We are trying to overcome that issue by installing more solar powered networks, but again that comes with a cost. And security and remoteness of population. Balochistan is one of the most remotest areas in Pakistan, and security has been an issue for the past decade. And lastly, the financial sustainability of running these networks. That is a very big challenge as well. Can you move on to the next slide, please? I think when it comes to community networks, how it's impacting the local communities can be an important factor, but how do you measure about it? Do you measure it by the speeds they get, or do you measure it by the number of people getting connected, or do you measure it by the way it's changing people's life? What we have seen, we have conducted few remote case studies where people using our internet GIDAs in remote and rural areas have been able to achieve shielding scholarships to study in UK using those networks. They have been able to set up Facebook pages to sell traditional clothes and slippers and shoes made in those areas. They are also using it for trading local agriculture products, which is, I think, very important. And for us to achieve this change meant that we had to loosen our broader metrics on time spent and interaction. I think the change it was making in society was very important for us. Can you move on to the next slide, please? I think when rolling out such products, in our experience, we have to accept the uncertainty. The uncertainty can be in the form of security, the uncertainty can be in the form of financial sustainability, and the uncertainty can be in the form of the technology used. What we adopted was the three-step principle, that we were flexible to the technologies being used, we were open to experimenting and learning more, and we were ready to embrace the failure as well. I think it is important that we embrace failure as well, as it's not always going to be successful, especially in such hard terrain areas and challenging environments. And can you move on to the next slide? And the next one. Thank you. Make it happen. I think with community networks, you have to make them happen, and you have to have the passion to realize the importance and it can make, especially in contributing for connecting the societies to the ICT and especially the internet. Thank you.
Thank you, Arzak. A pretty amazing place to try to provide connectivity in Balochistan. Does anyone have any questions for Arzak? And Arzak, thank you for your email if people want to contact you directly. We may have some people you're in contact with from Georgia, actually, Arzak, so thank you for your presentation.
Thank you so much for having me. If you have any questions, you let me know. You can always drop me an email as well. And we are happy to collaborate and share our experiences of the project with the other members as well.
Thank you. And I was just curious, what up-down speeds were you getting with the VSATs?
Can you repeat that question again, please?
Or what were your uplink, downlink speeds with the VSATs?
We have 4 MB speeds with the VSATs.
Okay.
So, yeah.
Yeah, it's complicated. Very small aperture terminals, for those that may not know what a VSAT is, used around the world, particularly in developing countries. Thank you, Arzak. We're going to skip over to Federico Capuano, who is here to talk about OpenWISP. So Federico, you're up next, and this is OpenWisp, a hackable network management system for the 20th century. Can you give us?
Can you hear me?
Yep, we can hear you. Go ahead.
Great, great. It's great to be here. Thank you very much for inviting me to present. I will do a very fast presentation about OpenWisp. I think this is one of the right places to present OpenWisp because we have a lot of users from emerging countries which are building internet infrastructure, and they need to manage this infrastructure. They need to monitor the system, update the configuration, and sometimes the stuff is complicated. So OpenWisp aims to make this easier. So next slide. Quick introduction about myself. I'm Federico Capuano, open source software developer since many years. Started to contribute to Linux, which is a wireless community network in Italy. And from then on, I started participating to different initiatives on wireless community networks, promoted Battle Mesh, which is an event for mesh networks, collaborated with Fryfunk on Google Summer of Code to develop code. Now with OpenWisp, we do the Google Coding, which is a program aimed for students, pre-university students, so very young, which we teach them how to contribute to open source. Then from 2012 to 2017, I've been working on public Wi-Fi, basically. Cineca is a university consortium in Italy, and it runs the biggest public Wi-Fi networks in Italy, run by they are state-funded, these ones, and the Wi-Fi is free, or sometimes there are private companies funding it. I've been OpenWisp core developer since 2012 because OpenWisp is used by Cineca to manage these huge public Wi-Fi networks. And then I've been working on NetJSON, which some of you may know. It's a specification for a data interchange format for networking software. Next slide. So let's go ahead and talk about what's OpenWisp. OpenWisp is an open source network management system. It was started as a solution to manage public Wi-Fi, but it evolved into something that can manage different type of networks. It aims to make it easier for people, organizations, companies to manage and deploy their networks. And one of the very good advantages is that it helps to keep the cost low. So next slide. Next slide, can you hear me?
Yep, we're headed there.
Okay, great. So how do we keep the cost low? It's because it allows to automate repetitive actions. Oh, I'm running out of battery, sorry. I forgot to connect the electricity. Anyway, because automates repetitive actions, so you need less time, and your human resources will need less time to do things because many of the boring stuff is automated. And it fully supports OpenWRT. So in this slide, there are links which are put there. So later you can look at some of these links if you don't know some of these links. OpenWRT is great because it runs on a lot of hardware, and it runs also on very cheap hardware. And that's one of the reasons why OpenWisp is becoming so used in emerging countries, because they get this cheap hardware and then they need a solution to manage it. But if you want a more expensive, more fully featured controller, you need to look at Cisco or other solutions which are a lot more expensive, not only in terms of licensing, but also in terms of the hardware that you buy. It's a lot more expensive. So OpenWisp, of course, is open source. It doesn't have licensing fees, and there's no vendor lock-in. We aim to support as many hardware, as much hardware and as many systems as we can. Next slide. So before we jump to show you some screenshots and some of the features, I want to underline some very important features on the technical side. For those of you who are more technical, OpenWisp is really modular. It's composed of different modules that can be used independently or together. It provides a default installation that there's a let's call it a script that installs the system, which is quite complex, so it's not for everyone yet. But if anybody is a developer or has experience installing open source software, it should be fairly easy. The script installs this default installation, which basically uses all these modules. It is programmable and hackable. So it means that it's developer friendly. Developers can extend it at their own functionality. There's somebody who is talking in the, I hear the headphones. Can you turn off the microphone? Anyway, okay, go ahead.
Can you turn off your microphone? Thank you. So go ahead.
Oh. Thank you. So it's written in Python, which is very important because the old version of OpenWhisp was written in Ruby, which was not very popular back then. And can you hear this noise too?
Arzak?
Cancelled these literally why it is not cancelled.
What should we do?
Hi Arzak, turn off your microphone.
Can somebody turn it off for them? Maybe they're not listening.
Can you help us? Hang on a sec. Go ahead, Federico. I'm trying to...
Okay, thank you. So Python is really important because that means that the project is attracting new contributors, because many of the old solutions that were built before in the previous years are built in languages that not many developers use nowadays. So they're slowly becoming harder to evolve. It has an active and growing community and is becoming popular in emerging countries, as I said. Okay, let's go ahead, and now I can show you what OpenWhisp can do. You can go ahead again, yeah. So there's one of the features which is helps to keep the cost low is this auto registration feature. There's a video link there. There's no time now. You can see this if you're interested on YouTube later. So what it does is basically we can compile a default firmware image, which you just need to connect to the internet, and it will auto-register into the system, and you can prepare some default configuration called templates, which can be also differentiated by the type of firmware image that you do. You could do a mesh image, you could do a public Wi-Fi image, and all these images which will automatically register and download the default configuration which is available in the controller, and they will auto-configure itself. You have also the advantage that by keeping the configuration in the controller in OpenWhisp, you can update it anytime, and all the devices will, when you update a template, all the devices that use that template will update themselves. So next slide. This is how it looks when the device registers, except that the name is set. When the device registers, you will see the MAC address as the name. There is some information about the IP, the management IP, which is used by OpenWhisp to reach, if necessary, the device. There are some other information. Next slide. And here you can see there's, for example, backend. That's really important because with this solution, we are able to provide support for multiple operating systems. Even though now we only fully support for production usage OpenWRT, but later I will tell you something more about this. Then you see templates. That are all the templates that are enabled on the device. Go ahead. And there's also the device as its own configuration that you can tweak if you need to do some local customization. Here you can see a bridge interface, for example, and some other description. Go ahead. One of the very important features of OpenWhisp is its advanced mode, in which you can edit the configuration directly in .NET.JSON format. This is very important because if the UI doesn't allow you to configure a package, because of course we cannot support all the possible configurations with our limited resources in the UI, but we can allow you to write the configuration in a format that is then converted to the format that will be used on OpenWRT. This means, this is very powerful because it means that OpenWhiz can configure any package supported by OpenWRT, so it is a network automation tool for any software that runs on OpenWRT. And in fact, it's being used for many things, not just networking, mesh networks, but also some people are using it for SD-WAN now. And this is something that we didn't foresee coming, but it is happening. So that's why I underline this feature. This is not the only way to configure additional packages. There are also other ways that make it more easier for users, but there's no time to talk about that now. But you need to know that it is possible to have support for other packages. Yes, let's go ahead. So here you see different colors because it's an instance for a private company that wanted a white label, so that's why it's blue. And here we have some, well, the VPN automation feature. This is also another nice thing. It is possible to have the system automatically create VPN clients and create SSL certificates. Well, I called it SSL. It's basically X509 certificates automatically for clients, which can be revoked if needed. So this is also a very nice automation that makes it easier to connect clients, so devices can get their own VPN or multiple VPNs. So you can have a management VPN, you can have a traffic VPN if you want to tunnel the traffic to some other place, and so on. Let's go ahead. So let me open here the same slides on my screen so I see better. So yes, this is the geographic map. Nothing very interesting here, but you can go to the next slide, which is something more interesting probably that not many other open source software projects have. We added the possibility to place the device on an indoor map. This is also very useful for people that manage a lot of access point and devices in buildings, and nothing else to add. There's a possibility to specify the floor. So if you have multiple floors, and in the future we will build a general map with all the devices, both outdoor and indoor. But right now you can only see the single device on the indoor map. Okay, we can go ahead now. And another very important feature, especially for mesh networks and community networks which use mesh routing protocols, is the network topology collector and visualizer. So we have this module which collects data from multiple nodes and is able to draw the graph and show it. It is also possible, in the next slide, we can see that it is possible to go back in time and see how was the network at the previous day. So we have daily snapshots which are collected automatically daily, and you can see there that on the 11th of September of this year 2 links were down, but instead in the previous slide all the network was up. So it's really, yes, it's really useful to keep track of what happens in the network. And with the new feature coming next, we will also be able to do a lot of more automation regarding monitoring of these links. Yes, we can go ahead. Another important module, especially for ISP and public Wi-Fi, it's the free radius module. I added the logo there just to show, but it's not there in the web interface. Let's go ahead. Here, just a few screenshots. If anybody is familiar with radius, this module basically allows you to configure and manage the free radius database, so you can define the group checks, the traffic limit for each profile, and things like that. We can go ahead. And here another screenshot in which we show accounting data, which this is very used in ISPs to monitor how much traffic each device is consuming, or how much traffic a public Wi-Fi user is consuming, and if he has reached the limit or not, the free radius accounting feature. So The new free radius module provide all these features for free radius. And then we have also more stuff coming. In the next slides, we can see some previews and some mockups. These features are not released yet. Some of them are just mockups. Some of these images are actually some code running, not perfectly, but we will get there. So a very important tool for who manage network is being able to see how the network is performing, how much traffic is being consumed, and so on. So we can go ahead, the round trip time, you can see there, and packet loss. And this system is also extensible. It's designed in a way that it is possible to write new Python classes to write more checks. So it's really powerful, but it's not there yet. We will release it probably in the mid of 2019, hopefully. Next slide, you can see it will be also possible to see not only graphs, but also the current status of the device in a fixed, let's say, next slide is good. So you also have a table which tells you how much memory is left on the device, the load average, and things like that. And also, it will be possible to see the Wi-Fi, the channel, the DBMs, information, dynamic information about Wi-Fi, which is refreshed about every 5 minutes or every minute. That's configurable, so it will be quite fresh. Next slide. And this is a, I would say it's a prototype. It's not there yet. Less than the monitoring, but we aim to get there. So we are building a firmware upgrade module, which will allow, in the next slide, you can see that it's possible to upload firmware images, and we plan to offer an automated way to upload firmware images into the system after compilation. And in the next slide, you can see that you can you can select a build, and then you can tell the system to upgrade all the devices that are related to that firmware automatically. So we are building basically a mass firmware upgrade feature, but it will also allow to upgrade single devices. So experimental features that are coming in the future. These two, actually, we have implemented them last year, but the result is not production ready yet. So we have developed a Ubiquiti iOS configuration backend, which allows, from the same system that you have seen, to configure the native Ubiquiti iOS firmware. That's important because many communities prefer to not alter the firmware of the antennas for different reasons. So it will be important to land this feature in OpenWISP for communities, but also for wireless internet service providers. Then there's Raspberry, which is already supported with OpenWRT, and you can install OpenWRT on Raspberry and you can manage it. But we also plan to support the native firmware of the Raspberry, which is also very used in other IoT or type of networks. So here I'm getting to the end of my presentation. I try to keep it very brief. I try to condense a lot of information, but there's a lot more that we are doing. The community is growing, many different organizations, volunteers, Google coding students, a lot of young people from all over the world, lots of people from India, lots of students from India that they want to learn to do this stuff. They have fun enjoying programming, but they also want to learn programming for networks, which is something which I think is really important to spread, because it's not so common to find people who can code but also understand networks. Nowadays, it's very easy to find people who do web stuff, JavaScript, but it's not easy to find people who can do JavaScript, web, Python, and networking. And if we don't train these people to build these tools, we will not be able to compete with the big companies which have a lot of money and are able to build these systems, network controllers, which aim to lock you in. And once you're locked in and you have all their hardware, They basically control you, and we don't want that. We don't want that because they can increase costs anytime. They can put licensing on the controllers, and we don't want that. So if you think this is important for your organization, let's join forces. Come and talk to me, because there's a lot of activity and we're working on many things, and with the help of all these students and volunteers that are helping us fixing a lot of problems and also building a lot of features. And this is all done to help the communities in the world that are not connected for different reasons, of course, but I think it's not only ISPs, it is also because managing these networks is not easy. It's not easy. They fail, they break, they get hacked because the firmware is not upgraded. Sometimes some communities ask their participants to participate, but it's really hard. Sometimes it seems like you need a degree an engineering degree to do some of the things. We have to make it easier if we want people to really build their own networks, because otherwise it's really hard. I've done this many times. I helped to build many nodes here in Italy, networks nodes, and I see the common people that have this node in their houses, they struggle to log into the antenna configuration and see all this information. We ask them to upgrade their firmware, but it's hard for them. So we need to provide tools. There's a lot of communities, LibreMesh and other communities, which are building these kind of things. OpenWhisper is another tool that focuses on building a control panel. That's what it is. So thank you very much. The last slide, you can see the OpenWhisp logo. And you can see the link to the website, openwisp.org, if you want to find more information. And my presentation ends here. Thank you very much. And if you have any question here or later online, you can find me on Twitter. I'm very active there. You can find me on the mailing list of the several projects I participate. So it's really easy to reach me if you want.
Thank you, Federico. And we have run out of time in the room, and I'm cognizant of the fact that we maybe get kicked out. But what I may suggest, Federico, is we're going to take the Leandro's presentation into an online Gaia, and we may see if people have questions for you. Is that okay with you?
Yeah, sure.
Okay, great. So thank you very much, Federico. This was an excellent presentation. It speaks to the heart of some of the tech work that's going on in community networks. We thank everyone for your attention, and sorry we ran out of time. This was the first time that we've done 99% of the work online, so thank you to everyone that was hugely aware of that and synced up with us remotely. So this was kind of a big ask. Thank you very much, and stay tuned, Gaia. We're putting a draft outline together that we hope to hack with you at the next meeting in Prague, but you'll see us on the net where we are going to be running this all by you. So thank you again, and we appreciate you coming, and thanks so much to the presenters who are online with us. We're going to sign off and see you on the net. Thanks a lot.